Hello. Hello once again. Dr. Ramirez here at your service. We are now going to have another video tutorial. This time, we are going to talk about the use of computer-aided design, structural design particularly. So let me just show you. What I'm going to show you now is a computer-aided design for structural analysis and for design of engineering structures. So we are using here the Etabs. So what we are having here is we are going to discuss with you how do we use the Etabs. So once you have installed your Etabs and you are going to run it, you're going to have a new file. So if you would like to have a new file, you just click file here and new model. You click the new model and you will be asked to choose between save user default settings, settings from a model file, or built-in settings with. So that means if you are going to check on built-in settings with, you will be required to choose what would be the units that you are going to use. You can use either US customary, metric or metric SI or metric MKS. So let us use for this particular case a metric SI units. So remember we have three units that we are using, either the English, the metric SI or metric MKS. So we are going to choose here metric SI. And then the database that we are going to use is the AISC. I choose here 15M. So this is a modified version of the American Institute of Steel Construction, the 2015 edition. But you have several choices here. You can choose any particular code or specifications you would like to use for the steel section. So you can either use the American AISC, American Institute of Steel Construction. You've got the 14M or the 15M. So I will be using the 15M for this in this case. While we can also make use of ASTM. ASTM stands for American Society for Testing Materials. So we have here several modified versions. So you have 1, 2, 3, 4 ASTM specifications, but you can make use of any of those with whichever you would like to, or you can use any other specification. So let us stick with the AISC 15M modified version. And then for the steel design code, let me choose AISC. We have AISC here, LRFD, or you can use the Eurocode, whatever code you will be using. So let us make use of AISC LRFD 93. Let's use this one. Okay. And for the concrete design code, let us use the ACI. The ACI is American Concrete Institute. By the way, this is also the basis of our National Structural Code of the Philippines. So basically, we can make use of any version of ACI code, but the latest that I have here is the ACI 31819. So there are some other uh, new introductions on the code and the specification for concrete. So depending on the company you are working for, depending on the requirements of the structures that you're going to design, you will choose between all of those. So let me choose the ACI 31819 and then I will click OK. Then you will be asked now the grid spacing, the grid dimensions, meaning you are going to look in the plan layout, and you have story dimensions. So for the grid dimensions, you may either use uniform grid spacing or you can customize the grid spacing depending on your requirements. So depending on your plan, you can customize the grid spacing. You can specify the data for grid lines. But in my case, let me use a uniform grid spacing here. So you will be asked for this particular tutorial that we have, you will be asked to use identify, I mean, the number of grid lines in X direction. You can identify, so any value depending on your plan layout, the number of grid lines in the Y direction. So this is the plan. Remember, you are using the grid dimension refers to the plan layout. And then of course you have the spacing of grids in the X direction and the spacing of grids in the Y direction. So this depends particularly on the distance between the column or the span of the beam. Okay, so you can also specify the grid labeling option. You can label the grid. Okay, you may label the grid beginning XID. You can label from left to right, or you can label from bottom to top for the Y grid. So let me just use this customized grid labeling option that we have here. Okay. Then you will be also asked to identify the story dimension. So the number of stories, how many stories are you going to design? A typical story height. So let us use the 3 meters typical story height. So this is a standard typical story height that we are using usually for the design of any building or structure. And then of course you have the bottom story height, which is 3 meter. You can also, just like for the grid dimension, you can also customize the story data depending on your plan, depending on the design of your structure. So you can simply let us make use of the simple story data here. So for better specification, for better illustrations. Okay, and then you can add structural objects. It can be a steel deck, it can be grid only, or you can use a steel deck. You can use a staggered truss. You can use flat slab with perimeter beams, I mean, waffle slab or two-way or ribbed slab. So depending again on your requirements. So if you are going, let's say for example, we are going to use reinforced concrete, we are using two-way or ribbed slab. Okay. You just click on whichever you would like to click on. So let's say, for example, we start with, okay, so you would notice once we click any of those, there will be some data that you need to identify. So let me click two-way or ribbed slab. Then when you click the two-way or ribbed slab, you will be asked to uh identify if there are overhangs, okay, along X direction and along Y direction. If there are overhangs in your ribbed slab, meaning there might be some canopies, there might be some cantilevered portion. So that means those are the overhangs. So you can identify the left edge distance, the right edge distance from along the X direction of the overhang portion. In this case, let us use 0.15, 0.15. So these are all changeable. So you can change the value depending on your needs. So let us use the 0.15 meter here. Along the X direction, you are also going to identify, And then, of course, you will be asked to identify the structural system property. Again, these are all changeable. You may choose if you, according to your computation, you are going to use a slab thickness of any other value. So in this particular case, let us stick with the 100 mm. And then you will also be asked to determine the the column size. If this is a square column, so that means we have a 300 mm by 300 mm column. Okay. And you can check model column intersection as stiff slab, or you can check ribbed slab, depending again on the requirements of your design. The restraints at the bottom, you can identify whether there is a pin or a fixed restraint at the bottom. So if there are no restraints or there are no support at the bottom, or any restraint, I mean, at the bottom, you just check none. But in our case, let us use pinned connection. Instead of fixed connection. So let us try the restraints at the bottom is pinned. And then you are also going to identify the floor diaphragm rigidity. So you can identify whether the floor diaphragm is rigid or semi-rigid or no diaphragm at all. So let us check rigid floor diaphragm rigidity. And then, of course, you are going to identify the rib dimensions. So for the rib dimension, that would include depth, width at the top and width at the bottom. And then, of course, you have this spacing. The depth would include the slab. So let us try, because our slab here is 100 mm. There is a rib. It is a ribbed slab. So let us try the depth of the rib is 300, including the slab is 350 mm. And then the width top is, let's say, 150 mm. Again, this would depend on your plan. Okay. And of course, you have the width bottom and the spacing of the rib dimension. So you can either choose X direction or Y direction. So let us choose X direction. Then you are also going to identify transverse beam. So the transverse beam would again depend on your plan. Okay, so if the depth of the beam is 600 mm, you identify 600. The web width, or that means the height of the beam, that is 300 mm. So meaning we have here a 300 mm by 600 mm rectangular beam. And you will be asked to identify the load. So you can identify here, according to this, we only have the dead load and the live load pattern. So we identify the dead load. Let's say, for example, the dead load is 117.7. By the way, the is unit weight of concrete that we are using is 23.54 kilonewton per cubic meter, or that's roughly equivalent to 2.4 kilogram per cubic centimeter. That's the specific unit weight that we are using for concrete. So 23.54 kilonewton per cubic meter. And then we have the live load. The live load will depend on how you're going to choose your type of occupancy. So let's say, for example, we are going to use, instead of using a 4 live load pattern here, let us use 2.4. O sige, let's stick with the 4 kilonewton per square meter. So the value of the live load will depend on the type of occupancy, as I have mentioned. And then you have to visit your National Structural Code of the Philippines, since we are here in the Philippines, or you can use any other building codes, depending on your location where you are going to provide your where you're going to construct your structure. So, and then, since we have all the data here given, we can now click OK. And we can now click here OK. So let us just wait for data to be shown here. Okay. So you have here the three-dimensional. You are now given the three-dimensional view. And of course, you have the plan and layout. So remember that we identified that the distance from beam, column to column, I mean, is 6 meters. So you have 6 meters here, 6 meters, 6 meters. So that, again, that would depend on your plans and layouts. So that's how we identify the foundation, the structural elements for your design. So you can just edit. There are several tabs here. You can click edit, you can click view. You may define the different, later on we are going to discuss what are those definition or the material properties. You can draw, you can select, you can assign, you can analyze. Okay, after you have gathered, identified all the necessary information, you can analyze and then check the model, and you can display, show display here. Later on, we are going to discuss each by one. And then you have the design configurations here, the options, okay? You can have other tools, and of course you have the help tool here. So if you are going to edit, okay, you can add a model from the template. Okay, if you have a model template there, you can add, or you can edit the stories and the grid system. So depending on the number of stories, let's say, for example, you made a mistake a while ago on the number of stories or any property in the grid system. So you just can click here. You can add grid lines at selected joints, and you can add grid options. So there are, you can edit the grid options. You can glue joints to grid, or you can lock on screen grid system edit. And then of course you have the interactive database. You can replicate any of the elements here. You can extrude, okay, the joints to frames and extrude frames to shells, or you can merge joints, you can align frames, you can move joints, you can edit your frames. So you can divide the frames, you can join the frames, you can reverse the frame connectivity, or you can modify the entire show frame types. You can edit the shells. You may divide the shells, okay? And you can expand, you can chamfer. And there are other data here, other operations here that you can click on in the edit. Okay. Okay. And also you can define your materials property. When we click on the material properties, you will be asked, okay, what are the materials that you are going to use? You can add new material, you can add copy of material, or you can modify materials. Okay. In the define section, you can also identify or define your section property. So meaning depending on your preferences or depending on the requirement of your design, you can add section properties. Say for example, for the frame section, you can identify, filter the property list. You can choose among this, or you can choose all. You can click specifically what you want like to use for the frame properties. You can use either still wide flange, so that means that is an I section, or you can use C section, the channel, or T section, that means that the still T section, or you can use angle, double channel, or steel tube. That is a hollow steel tube. Then of course you have or it can be a hollow or a solid steel tube. You have steel pipe, then filled steel tube, filled steel pipe, okay, and all the others. So when it comes to concrete, you can choose a rectangular section for your concrete, or you can choose circle, You can choose encasement rectangle, encasement circle, or you can use precast. So if you going to use a precast concrete, then you can click on the precast. So when you say precast, those are concrete which have been constructed or cured before it's brought to the actual construction site. So it's been cured already. Then you have the concrete T, concrete L, cross box pipe for the concrete, or those are all the other choices that you have. So we have several choices here. Okay. So depending on your preferences and on your requirement, on the requirement of your design. So you can import new properties, add new property, you can add, you can modify, you can delete any material property which you think you will not be using, or you can delete the multiple properties. You can convert to the SD section, or you can copy, you can export the file. So let's say skip, cancel, just showing you how to do the definition. And then of course you can identify the spring property. So let's say we have the soil profile. So let's go to the point springs. Okay. So you can add new property for the point springs property, or you can choose, let's say you have soil profile here. You can add new soil profile. If you click new soil profile, you will be required to identify the shear modulus reduction factor, the soil hysteric damping ratio, or you can add soil layer. Okay. You will be asked to determine, sorry, you to click on the soil layer. So depending again on your requirements. So you can click, let us click here. Before I go to the other profile here, you can identify the soil layer. Okay, if there are several, according to your soil profile, you have several layers of soil, different types of layers. So you can identify, you can add soil layer. Okay. If you can add another soil layer here, then you will be asked to add what are the properties. There are two types of soils based on your um, soil analysis. So you can choose elevation of top of the layer. So depending on your soil analysis, the data here will be varied. Then of course you have the unit weight depending on the type of the soil. And then you have the shear modulus, you have the Poisson ratio, you have the cohesion, which is in kilonewton per square meter. Then of course you have the friction angle. Usually this is being used for soil which have a friction angle and a degree, and you have the shear wave velocity in mm per second. So you have, for you can also adjust the transparency here. Okay, so you can use the you can modify the soil profile. Okay, so there are several soil profile that you can use here. So let us cancel this one. Okay, let us go to the definition again. If you are going to define isolated column footings, okay, let us click on the add new property. Let's say the column footing one, that is CF1. The you can change the display color, whatever color you would like to. Okay, let's stick with this one. And then you have the isolated column footing dimension. So depending again on your plans, of what would be the length along column major axis, the width along column minor axis, and the thickness. So these are all again changeable. So you have 1.5 meter here or 1,500 mm. You can change any value of this. So let's stick with the 1,500 mm. And then the program for the footing embedment depth, let the program determine it, or you can use a user-defined footing embedment depth. So depending on the depth of the footing. Okay, on your plan again. So these are all, if you click the user define, you can say 2 meters, 100 mm, 200 mm. Okay, so in this case, we are using mm here. So let us use program define, determine. Okay, and then we just cancel this one. You can define. Okay, then of course you have several others here. So for our next video tutorial, we are going to identify all those data. So I have just introduced to you how do we click on the different buttons here in the Etabs. Or you would notice here we have several functions here. Okay, and you can quick draw. You can select the object, reshape the object. You can draw the beam, the column, the brace, or the plan and elevation and three-dimensional. Okay, you can also quick draw. You can, for the secondary beam, you can also draw the plan and the three-dimension. You can also quick draw the braces. You can also draw the floor plan or wall elevation, or you can use the three-dimensional. You can draw a rectangular floor wall or plan and elevation, or you can quick draw a round point, that is the plan. You can draw walls. You can quick draw walls. You can draw wall openings, draw links and plan, draw wall stacks, and you can draw design strips, draw tendons, and you can draw slab, rebar, etc., etc. So these are all the functions that we have here. Okay. So for next meeting, I will show you again example, this time example of uh, readily designed structure using Etabs, the computer aided design. So thank you very much for listening. I shall see you again. This is Dr. Ramela B. Ramirez. Don't forget to like and subscribe to my channel. Thank you very much. See you again for the next vlog. Bye-bye.